Hi, everyone. My name is Christopher Siegfried. I'm the senior architect at InfoVia. We are a consultancy. We do DataVault and DataVault automation. So I'm looking forward to talking today about metadata and why we need it. So first of all, let's bring you to a moment in time where you or a data modeler you know has just finished a portion of their model, right? DataVault is modular. They just finished a new part and they're really happy with how it looks. Please go ahead and switch to the next slide for this one. Now, when they do that, they know everything that's going on with that part of the model, right? They can tell you that the link had to have a dependent child because of whatever reason, and it couldn't be a multi-active and it wasn't quite a hub. And they know all the reasoning behind that. They talk about why they chose a particular hub business key instead of maybe the more natural business key, what kept them from doing that. They can talk about the satellite information they had. If they think there was a weak hub, like it doesn't have a satellite, you're like, why is that here? They know the reason behind that. So immediately after a model has finished, there is a lot of really rich information on the what's and whys of that model. But that information is not forever because that information eventually goes away. And this will only work with the PowerPoint, but if you can imagine it, all this extra context we have, back to the next one, please, thank you, or the previous one rather. All this extra context, all these extra notes we had, and the person themselves, right?
Sorry.
Go away. We forget over time the exact reasons why we did something, or the data modeler forgets exactly why he did that, or maybe he's even left the company. And our data vaults are forever, right? They're supposed to last the life of the company, not the life of our memory or the life of any particular data modeler. But our models themselves are limited to that model, that hub X, that links X, Y, Z. So we don't have a lot of that rich information. That was implicit information. It was not explicit. It was not recorded anywhere. All we had was that information while it was understood, while it was currently being used. And we have a working model after. We have a model that is semantically aligned to the organization. It is a useful model. It gives us the data we need, but we're lacking that deeper understanding of the whys in that model. And that is going to become a problem, especially as the data vault grows over time. We'll lose more context. We'll have less organizational memory of why things were set up a certain way, why decisions were made. And this is not only reflective of the data vault itself, this is also information about how the organization works, right? There was a lot of work by end users, by subject matter experts, by data modelers. Everyone helped build this representative model. And we lose so much of that data following standard modeling practices. We just don't have enough to convey what we need. All right, next slide, please. All right, so what we need is to expand our data vault to be able to capture that information. We need a metadata layer of our data vaults that talks about the data vault and why the data vault was created the way it was and how it is semantically equivalent to the business and in what ways. So we can keep that really rich data we had at the beginning when we made the model available for use as time goes on. Now, this is important for a few reasons. We're going to have an expanded semantic layer. We'll have a better understanding of the model's relation to the business. We're going to be able to talk more about the data vault. Its vocabulary will increase because we can actually reference the data vault itself. We can talk about parts of the data vault, why they exist, and how they work. And all of this is going to be integrated into the data vault. There is integrated metadata. It's not somewhere sitting in a Word document. It's actually a part of the data vault itself, accessible and locatable, just like any other concept in the data vault would be. And now the really exciting portion, right? The rest of it is exciting for a subset of us, data modelers who like that and like having that rich information, but it empowers AI. And this has been amazing. I'll go over a few examples at the end, but it changes the landscape entirely. Yeah, I'll get to it. It's amazing though. Chat GPT-4 or GPT-4 specifically takes all this metadata that we're talking about capturing and can really leverage what's happening. All right. So to do this, I want to talk about 3 different clients who had different types of problems and how those problems can be alleviated, if not resolved, by this metadata layer, this MetaVault sitting on top of your data vault. All right, next slide, please. Thank you. All right, so client number 1, this is a very technically competent client. They knew they wanted a data vault. They did a lot of research. They brought in a strong data team of 2 engineers, and they had them get to work with their automation tool. Now, these 2 engineers did a great job. They talked to the end users. They really understood what was happening. They built out requirements, and they put a model together for this high value business process. And they were subsequently both reassigned elsewhere in the company. Same time, both of them. So again, this is a very competent company. They said, okay, no problem. Let's bring in some more data engineers. Let's get them up to date on DataVault. And here you go, guys. This is where the last engineers left off. But when they looked at what the previous engineers had built, they said, we aren't comfortable using this data or providing this data. We don't understand enough of what is happening to say that we are doing this correctly. And this model was not incorrect. This had been validated by the end users. The data was in use in some preliminary reports. Everybody was happy with it. But there was not enough context or enough understanding about what was modeled for those engineers to be comfortable to pick up and run with it. And that's interesting that we can have a model that is correct, but still lack enough information to expand on it, to be comfortable using it. And again, this is because by itself, there is not a deep semantic layer. So what are their options? If both engineers had not been reassigned, one engineer, the new one, could have spoken to a different engineer and said, hey, what's happening here? Why is this built the way it is? And that would have been great. They didn't have that option, right? So their next option is to go back to the end users. And they will know what's going on, and they did. But on both sides of it, that's kind of unfortunate, right? The end users have already been through this discovery and explanation process with the data team. And everyone's already put some time into this and developed a working model. So why do we need to go back and do that again? And you have to arrange the meeting and find the right times and all that stuff. And if that doesn't work, you're stuck with whatever rediscovery you can do. So what is a better solution than retreading and asking and trying to find things out? And that is having all the data you need within your data vault model. The happy path is you say, hey, I don't understand what this is. And you interrogate your data vault and find out the what's and whys. That's happy path. All right, next slide, please. Okay, so metadata layer, very shallow in a standard data vault, and that's understandable. All we have are the relationships between objects. We understand that a satellite describes members of a hub. We understand that a link connects to different hubs. We have the other metadata we have is our smart keys in our object names. So here we see S transaction detail. We know from the S that it is a satellite. Nice. We know that transaction is the concept. Great. Satellite for transaction. And detail is what it is telling us about the transaction. And that's a little more vague, but it's not like this is an unusual satellite either, right? Sometimes that's what they get named. And it would be more convenient, maybe, or at least more descriptive, if the satellite was called S, transaction, information about transaction initiation time and type of loan transaction, including conversion to alternate loan type. That is much more descriptive. It gives us more to work with, but obviously we don't want objects named like that. So that is not at all convenient. All right. So what we can do instead, next slide, please. Is actually address what is in our data vault. Now, the most important part of this is hub concept. Because if you think about your data vault and how we build a data vault, what we're modeling, they're all business concepts. They're concepts that we have spoken to the business. We understand that it is the terminology they use. So we know that if they have customers, they call customers clients. We call them clients. That is the concept we're representing in our data vault. Similarly, we keep our scope in line with the organizational scope. If clients includes only people who have actually purchased product or set up an account or whatever, we mirror that in the data vault. It's really, really important that our data vault is semantically equivalent to the organization, but these important concepts are nowhere directly identified in the data vault itself. We don't talk about them. They are understood. If you have a hub client, the assumption is that there's a concept client, but the hub client is not the concept client. So what we do instead is we generate this hub concept, and we have all the business concepts that we're using in the data vault. So this lets us know what we have going on, what concepts we've captured from the organization. And it also gives us the ability to describe these concepts in greater detail. So it's not just transaction, which is by itself not terribly descriptive, but when we address this as part of our model, add it to the MetaVault so we can talk about it, we can give a better description about that transaction. We can say it is a record of the creation or of a loan or alteration of an existing loan. Alterations may be monetary, a change in the loan type, or a change in loan terms. We have so much more information just from that little blob of text talking about transaction. And now our hub transaction has a lot more meaning. The instances of transactions carry more meaning. We understand where that lines up in the business. And same for any data vault object that is involved with transaction. So we're expanding our semantic layer by including this rich metadata. And this type of metadata is generally called descriptive metadata, right? We're helping ourselves identify where something is and what it is. Even if we didn't know the definition of transaction and we knew it had to do with loans, we could leverage our descriptive information about concepts to try to find the right business term. Okay, so next slide, please. This is going to be the next client I'm going to discuss. They had a different type of problem. This client has a very, very mature data vault. It's been around for a while. They have 8 to 12 data sources. It's big, but they also have the issue of onboarding new members. That's how their hiring style works. Every year, maybe twice a year, once a year, they get a new member to their data team, and they have to get them up to speed on the data vault. Now, these new members tend to be very well aware of the organization and the organization's business processes, so they're comfortable with the vault once they understand how it works, but they still find themselves having problems navigating the vault, getting from one concept to another, understanding if there are record tracking satellites or effectivity satellites involved, if there's a current view they should be using. There's still a lot of ambiguity, especially with a large vault. And this is an increasing problem as the vault grows bigger and bigger and bigger, and more elements of the organization are incorporated into it. So next slide, please. We do have something we can do about it. We can provide structural metadata.
Okay. Christopher, if I just stop you there, we'll flip across and we'll put you into the PowerPoint, so you'll get your PowerPoint build.
Great, thank you. All right. So
Um,
structural metadata. Looking good on my side, Mark.
okay, good. All right.
Thank you.
Good. All right.
So this is structural data. We just talked about descriptive. Now this is the structural side of that. We're going to talk about how the objects are put together. And you can see to facilitate that, I've created an additional hub for each of the basic types of Data Vault objects. We have a hub for satellites, we have a hub for hubs, and we have a hub for links. And now this is what I was saying about being able to talk about the Data Vault. Now that we have a hub that incorporates each Data Vault object, we can address those objects if that is important to our organization. We can talk about when they were created, what their purpose was, the last time they were updated. All this information that was not within the vocabulary of the Data Vault before is now discussable. It is metadata. We can record data. We can talk about it and provide that richer metadata. In addition to the hubs, we have a set of links going to the concept. Now, this is really important because concept is our most important part of the MetaVault because that is what our entire Data Vault is about. And accordingly, each of the hubs, satellite, hub satellite, hub link, has a link to concept. And now we're adding context to our structural metadata. We're combining the descriptive metadata and the structural metadata. And now we can start asking some interesting questions. We can say, okay, I know that we have the concept of product in our Data Vault. What is every single object related to that concept? And we can answer that question. And if we want to know about those objects and what their purpose is, we can answer that question. And then if we have a question about how two concepts are connected in the Data Vault, how we can reach between store and product, well, that's pretty easy, but you get the idea, store and return. We can use this information we have where each object is tied through the concept to return however long of a chain you need to travel from link to link to link to connect two concepts. So there's a lot more we can derive about our Data Vault with this structural metadata. All right, now that brings us to client number 3. Client number 3 is a different situation again. They are a very large organization and they have purchased smaller organizations as they have grown. And as you might imagine, that makes data very messy. So client number 3 said, all right, we need to get this under control. They looked at their options. They did go with Data Vault modeling. They selected their automation tool, and then they selected some subject matter experts from each branch of the business that had been incorporated and said, go model your data. And they did, which is great. So 4 to 5 architects, data modelers went out and they modeled their portion of the organization. And then they got together and they tried to make it a single data vault, which is what they want to do underneath the parent corporation. And they started running into issues. They started wondering, and you could just click through the transactions or transformations here, Mark, please. Is this actually a hub? It's considered a hub by this place, but not by this place. Is hub A the same as hub A over here? Maybe this should not be part of this link. I really feel C as a hub shouldn't be a hub. It should be a whatever. So there are all these disagreements about how the model should look. And those discussions again, and the decisions that are made is going to be a lot of rich, important data, especially in such a confusing environment where we're trying to bring many different vocabularies under the same understood parent vocabulary, where everybody knows they're talking about the same thing. All right, next slide, please. But because we've gone through this process and we've provided the MetaVault so we can have lots of metadata, we can talk about what is happening. So you see up there on S concept definition, what we've done is described 3 separate things. There's an invoice, there's a sale, and a sale transaction. And this is very close to the actual problem, one of the actual problems this client faced. And as far as the parent sales department was concerned, there was no difference between a sale and an invoice. So their business models did not differentiate. It included both of those and had its own business processes regarding the income source. But if you talked to manufacturing, they said, no, we use invoices. And they were very particular and had a very specific meaning for invoice that they felt sale was not representative of. And on the other side, we had sale, which is a terminology used by the retail and service division. And they also felt that a sale was different than an invoice. So lots of different views of what it may or may not be the same thing, depending on who you speak to. So we created 3 different hubs. And because we have metadata available, we can say, hey, the hub sale transaction is actually both hub invoice and hub sale combined. It's just a view. And we specify that if you need to do any kind of record tracking, go do it on the original hubs. And we can even make this helpful link, L concept, sub concept, because we are talking about concepts. And doing this, we can recognize that invoice and sale are sub concepts to the larger concept sale transaction. As much as we try not to supergroup and subgroup, we are going to find situations like this where a given part of the business does not deal with the same grain. Okay, so that's brought us through some use cases, some places where the metadata might have helped us out if we had had access to it. Next, I would like to look forward. So not only are we problem solving with this metadata, not only are we ensuring our Data Vault maintains semantic integrity of the organization, that we can build on it, that we can navigate it as it grows and grows and grows, but we are building ourselves the base of what we need to utilize AI. GPT-4 was released almost a month ago to the day, and it's incredible. It's a huge increase over GPT-3. It passed the bar at like a 90% success ratio. It has a much better understanding of context and relationships without any training than GPT-3 does. So what you're going to see in a moment are some prompts that I've fed it. I gave it a very small MetaVault, so no actual data or anything, just MetaVault data about the Data Vault structure. And then I ask it some questions and ask it to do some things. And it's exciting and it's going to change everything. So yeah, let's take a look. Next slide, please. So first one, create a Data Vault bridge table from H Bell Schedule Power School and H Student Power School. Now, I didn't tell it what a bridge table was. GPT-4 is built by scraping the internet, basically, right? And because Data Vault is a mature data modeling system and it's been around for years, GPT is already aware of Data Vault and how Data Vault works. Satellites, hubs, links, no problem. It understands all this. So we don't need to retread that ground. Similarly, it knows what a bridge table is. So when I queue it like this, I say, okay, I gave you some information about a MetaVault. Tell me how to build a bridge table. It is able to. Please click to get past that. So that was my prompt. And here's its response. It looked at the information it had up at the top left there, and it saw it did not have a link, which makes sense because why would we be building a bridge table if we had a link? But I didn't need to tell it that. It went to L concept link, and it found Bell schedule, and it found student, and it found the shortest path between those two, and it built a bridge table. So there's the DDL it chose. Again, I didn't queue it, and it gave an insert statement to fill that bridge table. And I thought, that's great. That's amazing. That's super convenient. And I thought, you know what? But what if I want a different type of bridge table? So I told it to give me a template for the bridge table it built. And it did. It's like, sure, here's what I used. And I said, well, what if we change this? Can we change the template this way? And you'll notice the language I used to request a change in the template is how I would speak to a junior developer, roughly. I don't have to specify that in this template, in the first row that is selected, please rename that row to whatever. I just, hey, the first row, make it called row ID and remove the primary key, just for fun, right? Not because that's a great idea. And again, no problems, it changed the template. And now, going forward, it will use this template to build bridge tables. So it's leveraged the metadata, the rich metadata we provide, and it can help us. This is the step from being coalesced, the automation tool, talks about being column aware, and we've all seen how amazingly useful that is. This is being DataVault aware. This is providing sufficient metadata for an AI to go out and do whatever process we want done on our data vault, to recreate it, to modify it in whatever way we need done. It becomes an excellent teammate. Probably still want to peer review its code, but yeah, it's incredible. All right, next prompt, please. Let's keep rolling. All right, record tracking satellites. You can't get away from them. So I don't like making those. I thought, hey, can it just do that? If I just tell it to create a record tracking satellite for a hub, can it do that? Now, in this example, I have specifically fed it a false stage table name. But, and this is a limitation of the chat component of ChatGPT-4 right now. You can't just say you can reference these data structures. You can't just say, just go check these tables. That functionality is coming in the next few months, I assume. But right now there is a limited data set, so I couldn't give it a complete model. Okay, so stage table, set its name stage here. And I said, query it, that's what you should do. Show me how you build it, show me how you query it. Give that a click, please. And it does again. It goes ahead and it creates the record tracking satellite, and it creates the information needed to load up everything about that. It checks the stage table, compares it to the satellite, or hub, sorry, in this case, and it returns that information. And again, if I didn't like how it went about doing this, we could tell it to do it a different way, and it will remember and do so. If we want to use this to generate templates for our existing automation tools, we can do so. The possibilities here are basically only what we want from it. All right, final prompt, please. Select a random satellite in the MetaVault and create a tracking object in the style the article suggested. This one's fun. So I wrote an article on LinkedIn about an alternate way to create tracking objects, effectivity satellites and record tracking satellites. And I didn't think this was going to work, but I gave it the article. I said, GPT, here's an article, read it. And then I said, based on the article, based on what I just said, build the DDL for an appropriate, to track a random satellite. Click, please. And again, it delivered. And it broke down why it did it. I'm not sure if I mentioned that as we were going through these slides, but it's providing information about the steps it goes through to make these choices to create this DDL. So we have the ability to see why it did that and the manner it does it. We can adjust both those things. Say, hey, don't go through this way. That doesn't really work for me. Do it this way. Don't build the template this way. Build it this way. I like my things to look like this. So it's fully customizable and it's in human language. We don't need to use Pebble or some specific templating language to get it to generate what we need it to. And again, I'm just so impressed because this was no prompt, no training, just read it, do what you read. So the future is here. This is going to change how we work with absolutely everything and how our existing automation tools work. And I'm really looking forward to seeing what other people are going to come up with. But again, you need that rich metadata layer in order to do that. this GPT portion, like I said, GPT-4 came out a month ago. I've been preparing this presentation and my research longer than that. So when this came out, it just fit so well with the expanded metadata available in a data vault. When you build this MetaVault, all that extra information, and you could just do so much with it. I'm very excited.